Welcome everyone. Welcome, Jessica. So Dr. Jessica Brown is originally from Central Pennsylvania and has a background in wildlife biology. She quickly became interested in studying ectoparasites of wildlife while conducting undergraduate research on white-footed mice. She completed her PhD in ecology at Penn State in 2024, and her dissertation investigated behavioral responses to black-legged ticks in multiple rodent hosts. She's now a postdoc at the Connecticut Ag Station, where she works to evaluate and advance area-wide tick control. Thank you for being here, Jessica.
Awesome. Yeah, thanks for having me. And thanks for the introduction. Today I'm going to be talking about kind of what we've been working on here at the station in recent years and kind of where we're headed next, specifically concerning host targeted control of ticks. And I'm going to focus a lot today on kind of some advances specifically in the delivery methods of these control tactics. Most of this was covered in my introduction. I am kind of new to being in this kind of field out of grad school and haven't met many of you yet. So yeah, I did all of my schooling at Penn State, originally from Pennsylvania. And my background is in wildlife science. And that's when I kind of fell in love with parasitology and ticks. And since then, I've been working in the tick realm and getting to do a lot of research, teaching, and outreach, and loving it. And so, being at the Ag Station now, working with Drs. Williams and Linsky, has been really fun so far. And I'm coming up on a year of being here. So, kind of jumping right into the content now. So today's going to be focused around Ixodes scapularis, even though we do have other tick species of veterinary and medical concern in Connecticut. This is our big one. And it has been based on kind of the historical records over the last century or so. It has been expanding up the eastern half of the United States and is thought to be reclaiming its like prehistorical range. And really, we're seeing with this coming increasing numbers of Lyme disease cases in humans. And so there's a lot of focus put on the black-legged tick, which is what we're going to focus on today. And I was actually just discussing with Jane and Nolan a few minutes ago that really to have success at this point with the how common this tick is and how much of a problem it's become, the primary strategy that research is focused on, as many of you probably know, is taking an integrated management approach. And so when we think about this system, we kind of have like different players. So we've got the pathogen being Borrelia burgdorferi, the hosts being many different species of wildlife, and the vector being the black-legged tick. And so ideally, to have successful control and management and kind of break this cycle, we would break the cycle of disease at multiple points. And so what this can look like is controlling the ticks themselves, which is what Megan spoke with you guys about recently with her spray work. We can control key hosts, which I'm not going to talk about today, but some work has been done previously, especially with controlling deer populations, for example, or we can control ticks on hosts, which is referred to as host-targeted control, and that's what we're going to talk about today. So host-targeted control is really advantageous, especially in this system, because with a 2-year life cycle of the black-legged tick, it allows, and 4 different life stages, including the egg, it can allow us to treat and interrupt the tick cycle at multiple different stages. And so the juvenile life stages, including the larval and nymphal black-legged ticks, feed primarily on small mammals, small and medium-sized mammals, and sometimes birds. And so by targeting white-footed mice, which are kind of like the big name in this area because they're a really key important reservoir host for Borrelia. So targeting them can allow us to target these life stages And then targeting white-tailed deer can allow us to control adult ticks while they're feeding on the deer. And white-tailed deer are kind of a key player in this realm because they are a really important reproductive host, a really common host that adult ticks feed on. And obviously they need that blood meal to be able to reproduce. So I'm going to talk about mice and deer, if you hadn't guessed already. But we're going to start with talking about white-tailed deer. And as I said, we care about them a lot because they're a key reproductive host of black-legged ticks, and very common across the eastern United States. So kind of the traditional, one of the most common ways in recent decades that white-tailed deer have been treated for ticks is through the use of four-poster feeders that you can see at the top here. Um, this takes kind of an approach that treats deer topically by using soaked paint rollers or bottles with permethrin. And when the deer reach in to retrieve the corn feed, they come in contact with this topical treatment. Um, and this is, I want to preface too by saying like none of what I'm saying today is to say that these methods, what I'm calling kind of the traditional methods, are ineffective because they have been found to have success in reducing tick populations. But kind of the work we're focused on is improvements and advancements, and so taking this the next step further and thinking about the ecology of the system. And so traditionally, we have the use of the four-poster feeders. And what we are working on here at the station now is kind of what I like to call like a new era of host-targeted treatment, where we're using, I'll refer to them as spinner feeders, which you can see on the bottom picture here. And this allows us to treat the deer systemically instead of topically. And so relying less on just the deer's head and neck coming in contact with a topical treatment, relying less on maybe weather conditions, grooming habits of the animals, and taking a systemic approach where they ingest the treatment and it can be circulated throughout their body. And this delivery method is through different variations of acaricide laced bait. Most frequently, what we've experimentally been using is acaricide laced corn. So kind of like a liquid mixture mixed in with a big vat of corn and added to these feeders. And so I'm going to talk a lot about these feeders and the benefits of them and why we're focusing on them so much. So the spinner feeders, there's a lot of benefits. Firstly, they are programmable. And so with a four-poster feeder, you're refilling the corn and it's gravity fed. So the individuals have constant access to the corn until the corn runs out. But with spinner feeders, we can actually program them and tell the feeder there's like a little, here, let me go back. There's a little, if you can see this, kind of cylinder under the feeder that has batteries and an interface. And we can program the feeders to release feed at a certain time of day, and we can have them all release this simultaneously. So no matter how many feeders you have in a system, you can choose to have the feed release at the same time. This is awesome, an awesome feature because it allows us to easily program the feed release to happen at the peak time of daily activity. And this might change by season. And so obviously with the change in the length of day and animal behavior throughout the year, we see earlier or later peaks of activity. And so we might be treating deer in the fall to target adult black-legged ticks. We could also treat deer in the early spring to target adult black-legged ticks because they're active in both of those times. And so this is important, a really helpful adjustment to be able to make and control. It helps us, as we'll get in later, it helps us with interactions amongst the deer themselves. And it kind of can help us with reducing non-target animals consuming all that bait by having the feed spin out when deer are the most active. Ideally, the deer come consume the bait, and there's not a lot left over for the turkeys, for example, to come and take. not that we're trying to prevent them from eating it necessarily, but they're not our target. So we and so we don't it's ideal if we can focus on the deer. Another benefit of these feeders is that it's really easy to, through that same programming, it's really easy to control and measure the quantity of bait that's getting distributed. So with that programming, we can control what time the feed spins out. We can also control how long and at what speed that little spinner moves. And so we're able to, in fact, just recently we found out that we could um, really have a fine tooth like control on these feeders and measure exactly how much corn spins out in a certain amount of time. We can adjust that if batteries are varied between feeders, and maybe one isn't spinning quite as fast as the other, but we can have the slower spinning one spin a tiny bit longer. So the eventual amount that comes out is the same. And so that's really great for standardization of what we're outputting by the feeders. Um, we also are finding that the corn consumption can be, because of this ability to control the feed so closely, the corn consumption can be lowered compared to four-poster systems. Like I said, four-poster systems are gravity fed and not restricted unless you let the corn run out and wait to refill it. But because we have such control over this spinner feeder, we can really bring down the amount of energetic output we're putting to the environment because we don't want to like keep supplementally feeding the deer. That's not the feeding the deer is not the goal. Treating the deer is the goal. And so recently I've been working on a publication with some data that was collected using these spinner feeders and based on consumption per device each day and kind of standardizing it with just using a standard equivalent of caloric output per kilogram of corn. And then I looked up a bunch of reference studies that had used four-poster feeders throughout the years and had reported really comprehensive consumption data because not all of the four-poster feeder manuscripts I was looking at were reporting this data, but a lot of them do. And so I pulled several of them, standardized it by year and by the device consumption per day. And essentially what we saw here is that you can see the mean of the reference studies was around like 6.5 to 7 kilograms per device per day consumed of corn. And our study was around 4 kilograms per device per day. And so this was a pretty significant reduction of around 40% of corn that was being put into the environment. And the great thing about this is like as we continue pushing forward on this, it can be tweaked even more. Like depending on the population we might be dealing with of deer and the project goals and the number of feeders in a system, we could continue like kind of turning this amount down until we find that optimal level where we're treating the herd effectively and reducing the kind of energetic output into the herd. I'm going to talk a little bit more about systemic treatment now and why that's a benefit. So typically, a lot of studies have found that black-legged ticks parasitize deer primarily on their kind of their head, neck, and chest, sort of the front of their body. But when there's competition among different species of ticks, so this paper that I looked at here showed that when there were deer in a location that had great populations of dermacenter and ixodes, there was sort of a divide where the ixodes actually were parasitizing the body of the deer more frequently. And so this is kind of important for us to consider in Connecticut because we have numerous other species of ticks that parasitize deer, including dermacenter, including amblyomma. And so this is something we have to think about. And so ideally, treating the whole body of the deer rather than relying on a topical treatment on the front of their body is ideal. And so we're hoping that using the systemic treatment will target their body more effectively. Um, and there is evidence of kind of comparison of this in cattle that I found in the literature that showed oral systemic application was able to reduce parasites overall more successfully in cattle than a pour-on topical treatment. And then the last benefit I want to talk about it with spinner feeders is that it treats more individuals simultaneously. So there was some really cool work done looking at interactions amongst deer at four-poster devices. Um, and they found a lot of aggressive interactions and a competition happening at the feeders. And so I just pulled the pictures from that paper just to give you an idea of they frequently saw how they frequently saw aggression from dominant individuals against subordinates competing for the food. Here's some more photos of aggression. You can see the bottom middle, two bucks. And then there's the bottom left seems to be a buck and a smaller subordinate. And so competition and aggression is happening, and as well as kind of the nature of the way this feeder is structured. Um, doesn't allow many individuals to feed simultaneously. Granted, they could kind of like reach their head in, get a mouthful of corn, reach their head up as they're chewing, and another one could reach in. But there's still going to be those competitive interactions that are going to limit this. And oftentimes you can see there were a bunch of individuals visiting these feeders, but not necessarily accessing the feeder troughs. And if they're not accessing the feeder troughs, they're definitely not coming in contact with those rollers. And if any corn spills, they're going to eat the corn and not get treated at all. So then these are some photos from work we've been doing here in the past year or so of deer kind of more peacefully, seemingly more peacefully consuming the bait at these stations. There's a lot of occurrences of multiple bucks feeding simultaneously. And there's a lot of occurrences where there's two individuals or more than two individuals feeding simultaneously. I don't have it in here, but recently we had a picture of 15 deer all in one area, or like in one photo at one feeder. And the cool thing about this strategy is any deer that no, if the corn bounces way over here, any deer that eats that corn is going to get treated. It doesn't matter whether they come in contact with the feeder, as long as they're able to reach the corn, they are getting treated. And this isn't to say we never have competition or aggression between individuals at these feeders, but kind of anecdotally, and I would like to really quantify this ideally, but kind of anecdotally, it's not very frequent. And thinking back to what I was saying about the simultaneous release, we're simultaneously releasing corn from multiple feeders in an area all at once. And, this buck can't be simultaneously at all of those feeders at once. And so the hope is with that simultaneous release, this buck might say, like, I'm going to stay here and eat this corn that I'm already at. And this subordinate individual could hopefully locate the corn that had just been released at the same time at a different feeder. So we've done some pilot work with systemic treatment of deer, and this again is not published yet, but it's in the works. We were treating a confined herd with a moxidectin pour over, again, over corn, which this work is currently kind of put on pause because of some labeling issues with moxidectin. But this was, again, the pilot work that we have from the confined deer herd from 2021 and 2022. And so during these 2 years, the deer were treated in the fall, so like October to December-ish, to target black-legged ticks in the adult life stage that were feeding on them. And then blood sera samples were collected so that the parts per billion of moxidectin in their sera could be measured. And then we could look at that and compare it with the number of ticks that were counted when the deer were darted and processed. And so you can see here that I think that this graphic, more than anything, it calls for potential and like further investigation needed. But you can really see the blue line showing the mean moxidectin detected in the sera of the captured individuals. and the red line showing the mean ticks counted on the captured individuals, you can see patterns starting to emerge, especially in the second year, whereas moxidectin uh, was increased in the blood. We saw a drop off in ticks. A couple sort of asterisks here are that going as we go throughout the season, it's possible that there were just less ticks to be feeding on the deer. And so this is very much like correlation, but not necessarily something we can call causation yet. Um, and additionally, like the patterns weren't as strong, and there's a lot of like statistical kind of iffiness. So I think this just calls for more sample size is needed, and more repetition of this. And then something that is interesting though is that the treated corn was removed and replaced with untreated corn after the third sampling event. And we do see that the moxidectin that was detected in their blood started to dip off. And there was a slight increase right as this happened with ticks counted on the deer. And this was all ixodes, so focused on ixodes. So I think, again, this calls for this has a lot of potential and further investigation. Like I said, the moxidectin work is kind of on pause because of some labeling issues, but we're pushing forward with working on kind of this delivery system and optimizing it. So we're currently collaborating with some industry partners and trying to continue systemic acaricide testing. We're currently working with this confined herd still in Bridgeport. So there's this place called Lake Success Business Park that has a huge fence all around the property. It used to be like an arms manufacturing or testing facility way back when, and now it's undergoing environmental remediation. So it's kind of plopped in the middle of the city, and like I said, closed off with a fence and closely monitored. And so we're continuing to work on trying to optimize this strategy there. And then we're also hoping to expand and start answering some additional questions that might come up with this methodology. One of the foremost ones being what amount, if any, of like fecal excretion is happening of acaricides that the deer are ingesting, and how might that have potentially ripple effects on the ecosystem. That's obviously something we want to be taking into consideration and be aware of. So that's kind of something we're hoping to build into our work. Okay, now I want to talk about white-footed mice. Again, they are a key reservoir host for Borrelia, so we care a lot about them. And the up until this point, the most popular methods of treating mice for black-legged ticks have been topical delivery systems, for example, tick tubes, and what I'm calling here like the traditional bait box. Again, not to say these aren't successful, they are, but we're just trying to update them. And so we are using a systemic delivery system with a fipronil laced bait, using a bait box that is already commercially available. These boxes on the right here are just like boxes that are normally treated with bait to kill rodents, but we're adapting them to treat rodents instead of kill rodents. And so benefits here, like I said, this is an adaptation of an existing treatment system. These boxes are already available, easy to purchase. Basically, the rodents enter, they have to turn into a smaller little back area where the bait is located. A lot like how the traditional bait box works, where rodents have to enter to reach the bait, except here we're not relying on them coming in contact topically with a wick. Rather, the bait itself is treated. And this is also being adapted. The bait itself is being adapted from a bait called kaput that is actually has been used in the past to kill fleas on prairie dogs. So it's a fipronil laced bait. This was used kind of in like a small pellet form and put in the burrows of prairie dogs for them to consume and be treated. But now it's kind of being reformulated experimentally for us to test into these, let me go back, these little blocks. And so instead of a chemical in the blocks that's going to kill the mice, it's fipronil laced. And so we can put the blocks really easily on little pegs in these boxes. Again, I think this is a method that allows us to more easily regulate the quantity of bait output. Typically, the strategy from what I've seen in the literature with like what I'm calling like the traditional bait box is you fill it with some amount of bait and put it out and then leave it for a while and then bring it back and see like how much got consumed. Ideally, not all of it, or else the animals won't be interested in going into it to get treated anymore. But with this, we have these little cubes of bait, and we can easily regulate, okay, how many cubes and how many weeks or how often is our refill schedule. And so we're kind of like at the kind of like regulating it as we go rather than filling it and putting it out there and seeing how much gets consumed. And again, this is beneficial being a systemic treatment. There was pilot work done here by Dr. Williams and Dr. Linsky with this system where they compared control plots to plots that were treated with the bait thrown into Sherman traps, and then plots that were treated with these bait boxes. And so they did this again in 2021 and 2022. And you can see really starkly, like this is, I feel like this is beautiful, like environmental data compared to what often environmental data looks like, where we see the control, kind of see the population of ticks being found on parasitizing trapped and processed white-footed mice. And then we can see in the middle here the benefits of the bait in the traps. It did seem beneficial, but there was sort of a lag on it compared to what we saw with the bait box application, where it seems like, once they found the bait boxes, it seems like the treatment was pretty reliable for the rest of the season. And then in 2022, like they're pretty much the bait box treated plots. There were minimal ticks ever found on those animals. And we think this is probably a result of just a shorter time lag for the individuals to locate the boxes because they were put in the same place, the same places both years. So the next steps of this work are one of the things we want to do is improve our understanding of bait box use by small mammals. Again, even though we're able to regulate and measure like, okay, how many cubes are being consumed and how many are we putting out, we're still primarily measuring this by consumption, like bait consumption, but that doesn't necessarily tell us like who is consuming the bait. And so some other rodents that we frequently get that fit in our Sherman traps that would fit into these bait boxes in Connecticut here are meadow voles, shrews, chipmunks, and red squirrels. And we're not sure if they are consuming the bait and using the boxes. So hopefully pairing this with some cameras to determine that. I'm a big proponent for like focusing on mice, but also paying attention to other small and medium mammals in the environment because they can also, while they may not be as competent reservoirs for Borrelia burgdorferi, they do show capability many times or frequently show capability of being competent reservoirs. And so I think that one, it's just helpful to know we're inputting this implementing this strategy. It's just helpful to know who's using it. And two, I think this really could only benefit us, like understanding what other animals might be treating themselves with this. And then something else, I kind of mentioned this a little bit, is like trying to find that optimization level of like how frequently can we refill the bait where we get an effective dosage, but are putting out the lowest possible energetic additions to the environment. I should note as well, this bait has been formulated to be pretty minimally, like nutritionally beneficial for rodents. But we still want to find that optimal level. So initially during pilot work, the bait boxes were being refilled once a week with 8 cubes per box. But in 2024, we refilled the bait boxes only once every 3 weeks. And that data is kind of still in the works, so I don't have data on like tick attachment to show you from last year. But again, anecdotally, it seems like we were still having effective treatment. So data to be determined, but hopefully we're coming into that realm where we're finding this optimal treatment frequency. And so, lastly, I just have a couple slides here. Something kind of calling back to the beginning of the presentation that's really important to us is focusing on integrated control in kind of area wide because especially working for a state agency, we kind of go by the um, philosophy that, being having tick access to tick control shouldn't rely on your like socioeconomic status or anything like that. And so we don't want it to be like, okay, well, I can pay for tick control in my yard, but I don't care about my neighbor's yard. So we're hoping that we can kind of have an effect, greater effect of tick control on larger areas. And so right now we have around 160 uh, homeowners on our study in these two towns, Bethany and Woodbridge. I put this little graphic in here just for any of you that may be familiar with the New Haven area of Connecticut to just show they're kind of just like northwest of New Haven. Um, I found this graphic from the Ag Station that was made in 2018 that actually in New Haven County here, these two town borders where the incidence of Lyme disease in humans is the highest in the county was Bethany and Woodbridge. Um, and in New Haven County, we kind of sit right around seemingly like 100 nymphs, black-legged tick nymphs per hectare. Um, and so we kind of have this perfect like storm or this mosaic of people living in suburbs that are highly wooded. And there's a presence of wildlife. And obviously, with all of those factors comes presence of tick populations. And so in these areas, I put like kind of an aerial photo. It's a little bit funky, but it just shows you how forested these neighborhoods are. And that interface is just, yeah, like a perfect storm for people to end up getting Lyme disease, especially given this data that was published, showing that people most frequently get tick bites while they're spending time outdoors at home. And so, kind of to tackle this issue, right now we're experimenting with combining these integrated strategies that we're working on, especially with seasonal timing and dosing. So Megan, I believe, talked to you guys, like I said, about our spray applications and seasonal timing of those. So trying to negate or lower negative environmental impacts that come from spraying for ticks while also acknowledging that spraying for ticks works. And so trying to time those applications smartly and also trying to figure out like um, what is the best way to use our bait boxes to treat rodents? What refill frequency do we need? And obviously kind of expanding on our questions from there. And so we work on in these two towns, kind of we combine them together and we have assigned treatments that we're working on right now. We're coming into year 3 of this study, but it's only year 2 of treatments actually being on the landscape. And so we have different treatment groups that you can see listed here. And as we move forward, I think I'm just really excited to see this data come together. And that's kind of where we're at right now. And I wanted to make sure I left a lot of time, hopefully, for discussion and questions. And yeah, I just wanted to thank you. I always like to use this, I call him Dapper Deer on my final slide. And an acknowledgement of CDC as our funding source. Here's my information and also the information of Dr. Williams and Dr. Linsky. And yeah, I'd love to chat or take questions and answer them to the best of my ability.
Thank you, Jessica. That was great.
Yeah, thank you.
Yeah, if anyone has questions, please feel free to ask them or raise your hand, drop them in the chat, whatever works for you.
Jessica, I have one quick question with the treatment of the deer.
Yeah.
Um, or I get so people hunt in Connecticut, I'm assuming. And
Yeah.
so is there a
Hmm.
certain level of like the test article or the
Yeah.
medication that has to like is there a level where like you're able to consume the meat? Because I know it's
Mm.
they use it in cattle, so I'm assuming there's a level
Right.
where I don't know, there's like a
Right.
washout period.
Yeah.
Um,
Yeah.
How would they
Yeah.
deal with that? I don't know if
Yeah.
you thought about that.
Yeah, so that actually is a big piece of like why we were initially trying to push forward with the use of moxidectin. Moxidectin is related to ivermectin, but has a shorter, its withdrawal time is what we call it. So the amount of time you need between the treatment of an animal and when it's safe for human consumption. And so in the literature, it's shown that moxidectin has like a 0 to 1 day withdrawal time. So essentially, that in theory would make it safe for human consumption if that deer were to be harvested. However, again, because of like the labeling issues, it's something that we can't pursue right now because it's not labeled for that use. Um, and yeah, so that's kind of the holdup is like other systemic treatments like ivermectin, for example, have a much longer, I don't know off the top of my head what it is, but a much longer withdrawal time. And so that does create more issues with the potential of human consumption.
Thank you.
Yeah.
Dr. Rich, looks like you have your hand raised.
Hi, Jessica. Thanks. That was great.
Yeah, thank you.
I had a question going back to your comparison between the four posters and the spinner. You
Hmm.
said that you see considerably less consumption of the corn. Can you actually measure the corn consumption, or are you just measuring the corn that's going out of the spinner? Because I know
Yeah,
in the hopper of a four poster, you know it's been consumed by something,
right,
maybe not a deer. But
right.
when it goes out of the spinner, do you have some way of like sort of quantifying what's being consumed
Hmm.
by deer?
Yeah, that's a really good question because it is that different delivery method. And what we've been finding is pretty frequently that when we first put our feeders out in the environment, um, we'll go back to do a refill, say in a week, and there will still be some corn on the ground. But once the deer kind of like figure out that the feeders are there, we start noticing that like all the corn is cleaned up. Like they do a pretty good job. Once they find it and they're hitting it hard, they like clean it up. And so what we've kind of been finding is that maybe starting with some untreated corn to essentially help them find it. And then switching to a treatment. So having a little bit of that like time in the beginning for them to help them out with finding it before you start the treatment. And so I think based on what we've seen with that, we can kind of say that the amount that's reduced from the barrel of the feeder is what's being consumed. Um, but I think that there would have to be more consideration taken if, say, you were working in an area that wasn't like this kind of confined herd space and maybe the deer density was lower around one feeder and we'd have to find some way to try to quantify what might be left on the ground and take that into consideration. So that kind of is in the back of our heads. But right now where we're working, the deer are like, great, thank you so much. And they're vacuuming it up. So yeah.
One more question just to add on. So, just from my understanding, so the Lake Success site that you talked about has the
Yeah.
fence about it. Is that fence exclusive? Does it leave deer out or leave deer in, or how does it?
Yeah, so we think there's like minimal to no like here, let me go. It's we think there's minimal to no. So the fence, funnily enough, the fence is actually meant to keep people out. But
Sure.
it's about 10 feet tall and has barbed wire on the top.
Uh-huh.
Um, and so we think based on just like capture data, camera data, and kind of just spending a lot of time on the site, we're pretty sure there's like minimal to no deer that like move in or out of
Oh,
that
interesting.
fence. We're pretty sure right now the population of deer in that business park area is around like 35 to 40.
Interesting.
Yeah, and I should have put in how large. It's a pretty big area. I don't know off the top of my head how many acres, but we go in there and we often see like 7 to 10 deer together, just like watching us up on the hill. So yeah, it's a pretty weird place.
Thanks.
I just have a quick question.
Yeah,
And that is when you were doing the stuff with showing the reduction of the ticks, linked with the amount of the whatever the stuff that you can't use anymore.
yeah.
There.
Yeah.
Is it possible to do to have data from deer that haven't been treated at all? That would be really cool to be able to see that.
Yeah. That would
Obviously,
be,
it would
yeah.
have to be in another location
Right. Yeah.
entirely.
Yeah. That would be very cool. And I like that would only benefit our kind of our case here.
Totally.
And yeah, it's tricky with the way that we're implementing this right now because we're trying to focus on one site and one population. But that would be incredible, yeah, to
Or
have that data.
or even if you can't use the Moxie anymore,
Mhm.
you do it, you repeat it again now.
Yeah, in the same site. Yeah.
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 Okay.
That's true. Yeah. That's a
Because you
that's a
got
cool
nothing
idea.
else to do.
Yeah. Yeah. Yeah,
Okay.
that's a cool idea. You're right. Thank
Okay.
you.
Yeah.
Yeah,
Sorry.
I don't know who had their hand up first. I guess I'll go with Patrick because you're at the corner of my screen.
Yeah, thanks, Jessica. So we haven't met yet, but my name is Pat, and I'm a postdoc in Dr. Rich's lab here at UMass Amherst. And
Okay, cool.
thanks for talking. That was great.
Yeah, thank you.
I have one question, actually, it has to do with this slide. So I'm glad you went back to this slide.
Perfect.
I'm curious, what's the makeup of the ticks on those deer when you're counting them? It says, mean ticks counted.
Yeah.
Does that mean that the ticks remaining on these deer are all males because all the females have fed and ingested the Moxie and dropped off? Or are you still finding lots of engorged or less engorged females on the deer? But what do the ticks look like on these deer with high levels of moxidectin?
Yeah, so that's a good question. And that's actually something I kind of forgot to put in my like next steps slide as well, was that we are kind of theorizing that the moxidectin, so because it's a systemic treatment and the ticks have to feed to come in contact with the treatment, we are kind of theorizing based on literature that the moxidectin may, like, the tick is already feeding and like it's cemented, and moxidectin may kill it, but not necessarily cause it to drop off. And so I wasn't like here yet when this work was happening, so I personally don't have like anecdotes of what the ticks look like, but pictures I've seen, and just talking with people that were out there with handling the deer, is that either there's fewer ticks, or the ticks are still like the ticks that were on the deer were still engorged and like in different stages of engorgement. And so this study didn't do any removal of the ticks, but that's another thing we would like to add in, is like remove the ticks and see like, are they alive even? And like what is the kind of the mode of action of like how this chemical is affecting them. So yeah, that's kind of a question as well still too.
Great, thanks.
Yeah. Andrew?
Yeah, thanks. A really nice set of overlapping interventions. It's great to see.
Thank you. Yeah.
Yeah, a tiny follow-up there. So the tick numbers here were from darted counts, or okay.
Yeah.
So you go through and dart a certain
Yeah,
number.
we have like a collaborator that does a lot of deer like darting and capture that helps with processing. So yeah, this was all from darting. Yeah.
And then you left them on. So there's no
Yeah.
Cool.
Yeah.
And the other question about Moxie, based on the dosage level in the corn, do you have any idea how much corn a deer needs to feed on to get sufficient blood levels? Is it like a cup or less, or?
So we're not sure how much corn the deer would need to ingest. But we are fairly sure, again, based on like previous literature, that the level of parts per billion of moxidectin in the deer blood sera only needs to reach about like 5 to 7 parts per billion. And we were seeing that, like, we were seeing a lot of deer with much higher than that levels if you look at like the full database. And so, yeah, I'm not sure. That would be it's kind of a cool thing to try to figure out. Is like maybe like even more so limiting the amount that the amount of corn that would be getting output. to see like what does it take. But yeah, I mean the spinners only output about, I want to say like 20 pounds of corn like at a time. And so
And that's over like a 1 day period, or?
yeah, and that's like what we've got going currently. And so the yeah, the deer we don't think they need to eat very much of it to reach that like level, because the level in there that is required in their sera is so low. Yeah. But we're not working with moxidectin right now, so it's also like a little bit different. So
Yeah.
yeah.
Okay. It might be fun, maybe you've already thought about this, is trying to estimate the feeding amounts from camera traps, but be really complicated. I've
Yeah.
if a few deer will eat a lot and then some will eat less, but if they all hit the
Right.
potential, then it doesn't
Yeah.
much
Yeah,
matter.
that would be cool, because we do have we have cameras on all the feeders, and a lot of the deer at this site, because it's because it's this herd that's been worked on before, a lot of them have tags, and so
Oh,
it
nice.
is
Okay.
it's
Yeah.
not too hard to track individuals. So yeah, that would be cool.
Okay, and then one other clarification from the bait boxes.
Yeah.
You said you were putting in 8 cubes a week.
Yeah.
And were those mostly consumed when you went back a week later?
Yeah.
Partially?
So yeah, initially in the pilot work they were putting in 8 cubes in each box per week, and I think that again, I wasn't here for that, but I think that they were not always getting consumed. But this past year we were putting in the 8 cubes in each box every 3 weeks. And I did do a lot of that work with refilling the boxes, and I never found a box with bait still in it.
Okay, so somewhere
so
between is probably the sweet spot, but okay.
Yeah. So yeah, we're kind of fine-tuning that.
Okay, awesome.
Yeah.
Thank you.
Thank you. Tom?
I just had a logistical issue. So having done the 4-poster stuff before and carrying out 50-pound bags of corn, I'm wondering how you add new corn on a daily basis, 20 pounds to those spinners.
Yeah. So that is a good question. So the feeders, the drum here, let me go back to so this isn't a great picture because it's not showing the full size of it, but let's see. The barrel on the feeder holds about 150 to 200 pounds of corn. I'm trying to do some quick mental math, thinking about how many bags we put in. So, and this is where the programming comes in, is like we can tell the feeder how long and like what speed the spinner needs to go and how many times a day and at what time of day. And so we really only need to go out and refill the feeders once a week or so. And usually by then they're not even quite empty. And so, yeah, we don't have to be out there every day. It is still about once a week, and we do we do climb up on a pruning ladder with bare buckets of like 5-gallon buckets of corn and dump them in. But we only have to do it once a week, thankfully. So, but having that large barrel and the programmability allows us to not have to be adding in that much each day.
I have one question. I see that there's a raccoon at the bottom right-hand corner. For off-target hosts,
Yeah.
does it have like that same effect, or is that treatment specifically for?
Yeah. The typically the products that are used for these systemic treatments are like very like general antiparasitics. And so while we haven't like trapped and captured like turkeys or raccoons or coyotes, we don't necessarily have reason to believe it would negatively benefit off targets. And granted, that's coming from a place of we haven't like looked at them. But just because we're using trying to use as low a dose as possible of like a very broad antiparasitic, hopefully there's no negative effects coming. And hopefully all we're doing is just treating other animals for parasites as well. So, Lars, do you have a question?
Yeah, I'm not sure how much you've talked to Scott and Megan about this, but there's an intriguing thing that came out of the first paper that Scott and Megan published on the Lone Star tick. Just having to do with how the moxidectin impacts the tick. It appears to be paralyzing them rather than outright killing them as fipronil or
Yeah.
some other products would do. So just in terms of figuring out the ins and outs of what happens to the tick if they are paralyzed while feeding on the deer rather than killed while feeding on
Yeah.
the deer.
Yeah, I'm glad you brought that up. I do remember, I think, talking a little bit about that from that Lone Star work. And yeah, so that is again, like, yeah, more questions of, yeah, like exactly what you said, Lars, like what happens at that point. And super cool that it like has a kind of a different mode of action from a lot of other chemicals that have been used in the past. So
Be an excellent project for someone with a deer pen.
yeah, it would be. If there's no other questions, I think we are about at time, 11:55. So
Yeah, we have 5 more minutes if anyone has any other questions. Maybe give it another few seconds for anyone to chime in.
and thank you all again for tuning in and listening, and also the awesome questions, because I love stuff like this because it gives me things to think about too as I'm working through this stuff with Scott and Megan.
Okay, well, if there aren't any more questions, then yeah, thank you, Dr. Brown. Thank you, everyone, for coming. And it was a great presentation, great questions and discussion, like you said. And we will see everybody for the next work in progress in 2 weeks on the
Awesome.
23rd.
Thank you all.